Math 3 Lesson Summary Video. Pied. This lesson is a develop understanding task, which is meant to introduce you to a concept, but not necessarily finalize rules or strategies. The purpose of this lesson is to use proportional reasoning to calculate arc length and the area of a sector relative to the circumference and area of the circle. After much debate, the club members have decided to slice the 8-inch round pies into 5 equal slices, or sectors, as the math geeks call them, the 9-inch round pies into 6 equal slices, the 8 by 8-inch pies into 2 by 4-inch rectangles, and the 9 by 13-inch pie into 3 by 3 1/4-inch rectangles. Although the pieces look alike, they are all about the same size. Some students think there might be a price advantage in buying one type of slice over another. Which slice of pie is the largest and which is the smallest? How did you decide? So we need to remember our area formulas in order to find how big the pies are. If we want to think about them as area, and we are assuming they are about the same depth. Most pie pans, cake pans, tend to be the same depth. So we're going to go with that their depth is the same. So we want to compare their area. If you recall, the area of a rectangle is length times width, and the area of a circle is pi times radius squared. So we have two basic shapes going on here. Our round pie pans, we have a 9-inch round pie pan and an 8-inch round pie pan. And then we have a square and a rectangle, which are both rectangles. One is a 9 by 13-inch rectangle and the 8 by 8-inch pan, but we know the slices are 2 by 4 inches and 3 by 3 1/4 inches. So we want to compare each one of these pie pieces to see which one's bigger. So we have our 8-inch pie pan, our 9-inch pie pan, the 8 by 8 cake pan, and the 9 by 13 cake pan. These two are circle pies, and these two are rectangular pie pieces. So let's find our rectangular pie pieces first. The 8 by 8 pan, we're doing 2 by 4. 2 by 4 is going to be 8 square inches. The 9 by 13 pan is 3 by 3.25. So 3 by 3.25 is 9.75 square inches. We always want to remember units of measure. Numbers don't have any meaning without their context and their unit of measure. Now for the round pies. I know how to find the whole pie. That shouldn't be a problem. But I don't know there's not a formula for one individual piece. But if I find the whole pie and I'm making it 5 equal slices, I can just divide it by 5 to get its 5 equal slices. So if my radius is 4 inches, because remember an 8-inch pie pan is 8 inches all the way across. That's a diameter. So if my radius is 4 inches, pi times 4 squared is going to give us 50.26 for the area of the whole 8-inch pie. But we want to make 5 equal slices, so we're going to divide by 5. And we're going to get that it is 10 square inches per piece. Now on our 9-inch diameter pie pan, that would be a radius of 4.5 inches. So pi times 4.5 squared is going to be 63.6 inches. But we're dividing it into 6 equal slices. So when we divide by 6, we get that one of those pie pieces is going to be 10.6 inches squared. So now we have all 4 of the areas for our pie pieces, and notice that the largest was the 9-inch pie, round pie. The next largest was the 8-inch round pie. The next largest was the 9x13 cake pan, and the smallest was the square cake pan at 8x8. So those are the areas, and now we know which pieces are bigger. The student in charge of quality control finds it's too difficult to measure the angle of a sector of a pie in degrees, and suggests that they cut out a piece of string that could be used to measure around the outer edge of the pie to let the servers know where to make the next cut. How long should this string be to measure the arc of a slice of pie for the 8-inch round pies? So we want to take the whole 8-inch circle and we want to divide it into 5 equal pieces. All right, so this is our 5 equal pieces. We said it was an 8-inch diameter, so that each of these radius should be 4. And we want to know, what should this piece of string be? We want to be able to lie the string along the outside of it, and it's going to cut it into 5 equal pieces. If we think about that, I don't really need to know what the angle is, because I can just take the circumference of the circle and I'm going to cut it into 5 equal pieces. So circumference, if you recall, is 2 times pi times the radius, or the diameter, times pi. So our diameter was 8, and if we do 8 times pi, we get 25.13 inches. That's the whole circle around the pie, but we want 5 equal pieces, so we're going to divide that by 5, and we are going to get that the string needs to be 5 inches long in order to get 5 equal pieces of the pie. How long should it be to measure for the 9-inch round pan? Same idea. It's just that this time we want to have 6 equal pieces. So we know we want to cut it into 6 equal pieces. We know that our diameter is 9. So if we're going to do diameter times pi, that's going to be 9 times pi. And that's 28.27 inches. And we're going to divide it into 6 equal pieces, which is going to be a string that is 4.7 inches long. And so this is going to give us the pieces of string. So instead of having to take a protractor and try to measure that little angle at the front of a pie, which I would imagine would be a pretty messy process, now we know how long that string needs to be in order to do it. A sector of the 9-inch round pie measures in degrees. What is its area and what is its arc length? So that's interesting. This time we're just dealing with theoretical numbers and not actual numbers. If we know we have a 9-inch pie pan, we know that its diameter is 9 inches. So finding its area for the whole circle and finding its circumference for the whole circle is not a problem. Circumference is going to be 9 pi, and area is going to be pi times 4.5 squared. So we know how to find the whole thing. The issue is knowing what fraction of it we need to use. Before we just divided by 6 because we had 6 pieces. That meant that we were using 1 out of the 6 pieces and we were multiplying it. We don't want to forget that dividing by 6 is the same thing as multiplying by 1/6. The issue is they're not telling us how many pieces that we want to use. One of the things that we've been working on for the past few days is the fact that the angles at the center are proportional to the arc lengths on the outside. So if I know what that angle is for the pie, the sector of the pie, the arc measure, or the angle at the center, I do know that that is proportional to the whole circle. So in order to get our fraction that we need to multiply these by each time, instead of being 1/6, like they were when we wanted 6 equal pieces, we need to figure out what fraction of the whole are we looking for. So that means that whatever this degree is, it's out of 360 degrees. And so that's going to replace our fraction in both of these. So in order to find an n degree portion of that 9-inch pie, I would have to do n divided by 360 times 9 pi, which is the circumference. And I would have to do n divided by 360 times pi times 4.5 squared, because that's the area. We can even generalize this more by saying we don't always know that it's a diameter of 9. We could do it for any circle if we just generalize using the radius of the circle. So if we know that the portion is n degrees, and we know that the circle has a radius of r, its circumference is going to be 2 times pi times r, and its area is going to be pi r squared. And so we can use these formulas to generalize finding the length of a piece of a circle, of its arc length, and of a piece of the pie, a sector of the circle.